All right, so to start off today, you guys are going to be graphing a topographical map. Topographical just means basically you show the elevations. If you guys have ever looked at like an atlas before, you'll see different colors for different heights. Well, a topographical map doesn't have those colors, but it does show a much more fine interval for your height change. And we're going to do it with a little beaker with some clay in it. So we're going to head over and do that right now. Okay, so for this section, we are going to be making a topographical map. For this, we're going to use our artificial blue clay mountains here. And what we're going to do is, as it's sitting here in the beaker, add 50 milliliters of water so that the level is consistently going up. It'll be the 50 milliliters as it shows on the beaker, so I'm taking into account the fact that there's clay in there. So it'll be the same elevation change each time. In your notes, go ahead and draw a circle where all of this is going to take place. And every time I fill it up, I want you to add the outline of what is not covered by water. So to start, go ahead and pause the video, draw your circle, and then inside of the circle, draw the edge of the clay the whole way around the outside. It may be up along the edge of the beaker. That's okay. Draw it as it is right now. Go ahead and pause the video and do that. I've now added 50 milliliters of our artificial swamp water around the outside. Go ahead and trace the new outline that gets made. So anywhere there's not water, I want you to draw the edge of our new outline for the shape. Pause the video, and in a second, I will add 50 more milliliters of water. 50 additional milliliters of water have been added now. Go ahead and draw the new outline, pausing the video so that you have time to look at it. An additional 50 milliliters has been added. Pause the video, take a look at the new outline, and draw it. We've got another 50 milliliters of water. Go ahead and draw it, and we should only have one more elevation change after this. Then we'll go up and draw it on the board together, and you can see how you did. Here is our last elevation. Go ahead and draw out what you see, and then we'll come back together on the board and draw it. So right here, I've gone ahead and drawn my circle, and I filled out the clay to the first 50 millimeter mark, or milliliter mark. The way I'm going to record this on here is I'm just going to write, for this line, I'll put a little break in it and write 50 ml. On a real topographic map, what we do is write the elevation, but for us, since 50 milliliters is representing our elevation, I'll go ahead and write that on there. Next, I'm going to add in the next layer. I've now gone and added the next layer. I'll put 100 milliliters on that one. You guys may begin to notice a trend about how closely or how far apart the lines are spaced. That starts to tell you something about the elevation change. We're going to go ahead and add the next layer, and then we'll see if you can start to spot the trend. Okay, this time you may notice I have two discontinuous shapes, meaning the lines aren't connected for the same elevation levels. On both of those, I'm going to go ahead and add a marking that tells you the elevation. You probably noticed this guy over here is just a tiny little peak. As you can tell, it keeps every time it goes up, 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 and then there's just a tiny little bit that's at that high elevation that's still above the water. And then over here, we kind of have like an inlet or maybe like an island. Remember, your drawings aren't going to be perfect. Mine's not perfect, but it's getting the general idea, helping us understand how topographical lines work. We'll go ahead and add the next line in just a second. We now have two more discontinuous peaks. These ones are now 50 milliliters higher. So I'm going to put 200 milliliters for each of those. These, on like a real map, you would assume that these are the peaks of two really tall mountains. So let's go ahead and add the last one and see what it looks like when we're all done. I lied. There's actually going to be one more after this one. But now this peak continues just barely above. Here's our 250 milliliter mark. And over here we have 250 milliliters again. If you want to just write it on top of the line, as long as it's legible, you don't have to erase the sections you've already drawn. For real this time, now let's go ahead and draw what our peak is going to look like. All right, so our final peak is right here. This is our 300 milliliter peak. And with a real graph, remember, these are heights. So we could even change it to be 50 feet. As long as we have a scale, we can tell what it's going to look like. But things we can start to notice from a graph, a topographical map, based on how closely the lines are spaced. So remember, each one you're going up in elevation. So if we start packing lines really close together, like we do on this side of the mountain, what we get is a really sharp, steep peak right here. Whereas if we were to come over to the mountain from this side, it's much more gradual. As the lines are separated further apart, you can think back to your Algebra 1 days where it's rise over run. Rise is every time you pass a line, run is the horizontal distance. So let's say I were to take a cross section of the map and I were to just go, I don't know, right across there. I want you to take a second, try and figure out what that would look like if you were to drive up this mountain. So pause the video, try it out. Maybe make a graph that looks something like this, where you have like your X distance and then your Y height. And then we'll come back in just a second and go over it. Okay, so you may have noticed I changed my graph a little bit here. I added height in milliliters on that side, and I added distance in centimeters. I went and measured this out. It's about 80 centimeters. So all I did was just plot all of the points where this line crosses. So here's my 50, my 100. On our graph, it's going to be very discrete. It only shows every 50 milliliters. But in the real world, the lines would be much more smooth. So I could connect the dots, or what I can try and do is just try to make a nice smooth curve that connects all the points. Either way, you're going to get a general idea of what the mountain looks like. So I'll do a little curve here to try and connect them all. There we go. So if you were to look at this mountain in profile and you were to see just that slice across, it would give you sort of this shape where you look at it. Very steep peaks up near it and sort of a plateau here on its eastern face. So if you were to look at this, when you drive it, you get a little bit of a bump here, but it really kind of levels out here, and then all of a sudden you just come up really quick. That's what we see here on our graph. Get a sharp, steep slope, kind of levels out, then way up. Then we got a huge section where we don't really change elevation very fast, and we see it over on here. Then we're going to head down the slope, and over towards this side, the peak gets a little tighter together. Our lines are close, so we should see a steeper drop-off, and that's what we see. And then it kind of levels off at the end as we go to the edge of the beaker. Now that we've done that, we're going to learn a few other map elements and see how we can use topography to help us make a map. Now we're going to learn a little bit about some of the elements that a map is going to need. And to start off with any map, what we're going to need to know is what direction we're looking at. And to do that, we need something called a compass rose. Now these can get really elaborate, they can get well defined, they can have a whole bunch of stuff going on. For the ones you guys are going to make in your maps, you can keep it real simple. All you need is just an arrow that points towards north. So we'll keep our map pretty straightforward, and what we're going to do is give ourselves just an arrow that points north. That's all we need for our compass rose. Next thing we're going to do is we need a scale. So for this, I'm going to go ahead and grab a meter stick and try and keep things consistent. This will be our scale over here. A scale just basically lets you know how big a map is in a one-to-one comparison. Some maps will give you like 1 equals 25,000, meaning whatever 1 inch is on the map is 25,000 inches in the real world. For ours, we don't have to go too crazy. Let's just say something right here that like 20 centimeters, we'll make that 2 miles. So this is 2 miles on our map. That means that every 10 centimeters is 1 mile. We can put that up there like this. 1 mile is there, 2 miles. Cool beans. Next thing that we're going to want to have with any contour map, you know how we drew those lines before, we need to show what our contour interval is. So contour interval. And this says basically what elevation change you're making for every height, for every line that you draw. We'll keep it relatively small on this one. We'll just say 10 feet. Most maps we're going to be dealing with in this class on a smaller scale are only going to have 10 or 20 foot intervals. You can get bigger ones where it's up to 50, but that's in really rocky elevations. And once we have all those, I'm going to come over here to the right, and I'm going to make a legend. And a legend just basically says what every map element is. We put a little symbol, and then we write out what it is next to it. So let's start out with some contour intervals. I'm going to pause the video at this point. I'm going to draw a map, and when we come back, you guys can take a look at my map. If you want to make your own map and follow along that way, by all means, feel free to do it. You're also going to have a lab on this pretty soon after you take the notes, so just be ready for that. So as you can see, I've got the map drawn here. We've got our contour intervals, and the thing that we need to do now is to label them. Let's start off this outside one. We can pick any arbitrary height, just as long as our contour interval between each one is 10 feet. Usually, if there's one line that goes all the way around and let's say super far, you only need super far apart. You only need to put one label. So let's say this is 110 feet here. That means the next one up would be 120 feet. That one's still contiguous, goes the whole way around the outside. This one's 130 feet, and then we'd have 140 feet here. So that's 1, 2, 3, 4. We may have a fifth one there. Let's see. This is 120, 130. This is 130 over here. Notice that when I break them apart, I have to put a new label on them. Let's go ahead and just put one really tiny one in the middle there, just so we get five contour intervals. And this will be our 150 feet on the inside. So that's our tallest peak. We got a hill here, hill there. And just to make things fun, let's add a depression. So when we have a depression, that's just something that sits lower down. What you do to mark your contour intervals is just put lines on the inside showing it's lower, and then I'll label this 110 feet. Cool. Now, once I have that, I'm going to go over here to my legend and just show that if I've got this, I'll just do an example shape. I'm going to write depression. Just to let them know that's what it means on the map. The next thing we're going to do, now that we have our elevation, is we're going to look at water. Now, water, if you noticed in the other part, tends to go in the lowest lying locations, meaning that when we do it over here on the map, we're just going to look for the lowest lying locations. I'll draw, I don't know, let's say 2 rivers, and for one of them, let's have it go into a lake too. So water wants to always follow the fastest path downhill. Let's say we got a river that starts up here. It comes off of the peak over there, and it's going to follow around. It's looking for the straightest path downhill. This here, these are 2 jutting in sections that go deep into where there's elevation, meaning these are going to look like valleys if we saw them. So I'll draw a river that goes right through the valley, heads on off our map. And let's pick another river. Let's say we have one that comes off of this, and maybe it even, let's change this. Maybe it's not a depression. Maybe it's a lake. And, well, no, we won't worry about that. Let's say we have one that just comes off of the mountain over here. It's going to go straight down. It's going to roll, and it's going to go into the valley. And our rivers are going to connect together. Remember, rivers are always going to go together, not go apart, unless you've got a delta, but we won't get into that. Rivers always like to form together because the lowest points tend to combine. We've got that, and let's say, you know what, I was talking about a lake. Let's just make a lake down here. Here's our lake. You guys don't have to use a different color. There's my weird shaped lake. We'll call it Lake Weird. I'll come up over here to my legend, and I'll put this blue line is a river. If you guys are using all one color, just kind of make it have a slightly different shape from your other lines. And then we'll show this right here is a lake. So that's a decent sized lake. It's about 2.5 miles at its longest point. Next thing we're going to do is we need to add in some of the human features that are on the map. For this, I'll go with green. Let's call any building. Well, let's put roads in before we do that. I want to add a road. Roads, I'm just going to make 2 black lines that go next to each other. I'm not going to go too crazy. I'm not going to make a lot of them, but let's say this is like a resort town near some lake with some mountains. So we'll have our road that comes here, and then it gets to water. Oh no. Well, on the lab that's coming up, you have to do a unique feature, 3 of them. One of them could be a bridge. So for bridge, let's say I make a feature that looks like this. And if you guys are wondering where I come up with these, you can just look online at other bridges, see what their features look like. If not, you can come up with your own shapes and decide what you want to make them. But let's say there's our bridge, and we have a road here that kind of goes up a hill. It keeps going in a straight line, but it doesn't want to fight that hill, so it goes this way. I'll just make up a name for it. We'll just call it like Route 45. There we go. That's our road. And then I'll make another road that goes up to, how about we have another one that drives up this way? And it goes up the hill to this point, and then it stops, and we'll call that Riverside Road. Cool. Now we've got our roads. We got a bridge. That's a unique feature. And then let's say now we need to add in our buildings. For this, I'll do them in a different color. You guys can do them in the same color if you're doing it on a map. However you want to do it, as long as it's clearly legible in your legend. Over here, I'll just make a square. This is a building. Let's say down by the lake, you've got a building here. Maybe that's the marina. And over here on this side of the river, we've got Bob's Bait Shop. And maybe up here, there's a, I don't know, let's say this is like a, let's call it the Mountain River Inn. Mountain River Inn. I'll add a couple more. Maybe there's an abandoned hunting shack. Abandoned shack. And we'll do one last one. Let's say on the other side of the river near the bridge, there's Tim's Diner. There we go. So I've got a couple buildings. My map's starting to fill out here. Let's see. What else can I add? Some more unique features. Well, maybe I want to make it real pretty, and I'll add another water element here. And I'll say there's a waterfall. This is a waterfall. Maybe that's why they chose to build the inn over there. They've got a good view overlooking the waterfall. So I'll go like this, draw my waterfall on the map. All right, cool. I'm starting to get some unique elements. Maybe I'll add one more. Maybe I'll make like a fire spotter tower. So out west, they'll have towers, and even some in the Appalachians too. They'll build towers up high where you can see fires from far away so they can know when to fight them. Let's say somebody built one way up on here, and I'll call that my fire tower or fire spotter tower. And now that I see that, maybe I'm like, how do they get up there? Maybe there's another road. Or I can continue the Riverside Road, and it suddenly takes a sharp turn, but I don't want it to go up, so maybe it switchbacks all the way up there. Takes zigzags all the way up. Cool. So you'll start to see stuff that makes sense on your lab. Or on your map, and you'll want to make corrections. That's fine. Just make sure you aren't writing in ink if you're doing it on paper. So our map's starting to look pretty good here. I'm trying to think if there's anything else I'm missing. I think we're pretty good. But let's say they wanted to generate a little more power for the town. Let's say they wanted to put in a dam. And let's say the dam is like 10 feet tall. If I were to put one in halfway up this river from the lake, and they were to put one in here, go ahead, take a second and predict what do you think is going to happen if they raise the water level 10 feet there. So now there's like a wall. What do you think is going to happen? So pause the video, make a guess, try it out. Cool beans. Did you try it out? Well, let's think about this. So if the water can't go over here, what's going to happen? It's going to start to fill up because there's no way, water's still coming in, but there's no way for it to go out. What's going to happen is it's going to start backing up. And all of this here, up to 10 feet, which from the bottom of there to here is 10 feet, because that's our contour interval. It'll fill up, and then we'll get another lake. That's actually how a lot of lakes in Ohio got made. They're reservoirs caused by a dam. If you guys have ever been to Alum Creek, you'll have seen that. And And we'll actually do a lab later on where you predict how big Alum Creek should be, looking at a map of it before it was made. So this is the general idea of topography and of mapping. Hopefully you guys are prepared for it. You get to make your own and we get to try it out. If you have questions, make sure you email me or ask me in class. And there it is, mapping.